that that some of the principals actually use this document as a book study. So Principles to Action, what's handy about that book is that it's the kind of book that one could pick up and turn to any page and get something from that page. It's not necessarily the kind of book that one needs to sit and read from front to back. Many of the pages have charts and tables that talk about different kinds of productive beliefs and productive practices. So they actually have 6 different principles for school mathematics, and I just wanted to highlight them and then focus on a couple in particular. So one is teaching and learning, that an excellent math program requires effective teaching that engages students in meaningful learning through individual and collaborative experiences that promote their ability to make sense of mathematical ideas and reason mathematically. The other thing that that kind of highlights, which also points to this access and equity, is this idea of a mathematics program for all students, that all students should have access to high quality math curriculum. All students should have access to effective teaching and learning. All students should have high expectations as well as support. I know quite often we hear of people who say, well, I'm a math person or not a math person. It's my belief that everybody's a math person, and quite often we end up with those feelings that one is not a math person because of the way and the approach that we were taught. It might not have been an approach that actually matched with the way that we think about mathematics or the way that we are as a mathematical person. So again, this speaks to that notion of access, equity, growth mindset. I believe we're all math people. And I think that it's an important thing that we instill, particularly in our students, in our teachers, and in our parents. I know I sat at many a parent interview where the parent would say, well, I was never good at math either. So as though that's kind of okay and means it's okay for that student. So I think we've got work to do in that area. Another one is assessment, that an excellent math program ensures that assessment is an integral part of instruction. So in other words, that we basically have this assessment integrated within our instructional practices. It's embedded, it's ongoing. It speaks to formative assessment. It speaks to paying attention to student thinking, giving feedback to students, but feedback to teachers to know next steps. Also, access to tools and technology. I always think about these kinds of tools as what I call mathematical thinking tools. It could be manipulatives, it could be technology, it could be iPads, it could be a ruler, it could be graph paper. So it can be simple kinds of mathematical tools as well. But each of these tools helps our students make sense of mathematics and represent mathematics in different kinds of ways. So that's an important component. The last two are professionalism. So in other words, in an excellent math program, educators should hold themselves and their colleagues accountable for the math success and personally and collectively think about professional growth towards effective math teaching and learning. So this importance of paying attention, staying on top of current research. One doesn't need to be reading research articles per se, but there are many practitioner journals, many professional learning opportunities that help teachers stay current with what some of the research is saying, but in a form that's more accessible to practitioners and has examples that they can actually take to the classroom. And then the 6th is curriculum. An excellent math program includes a curriculum that develops important math along coherent learning progressions, develops connections between math and the world and the different kinds of branches of mathematics. And I'm going to look at the Ontario math curriculum. And I'm going to focus on the Ontario math curriculum for secondary mathematics because sometimes we forget what it's actually saying. First, I want to talk about a little bit of background. I've been involved in the Ontario math curriculum development for a while, whether it's writing research, background research reports before a curriculum review, or many of my research projects actually look at curriculum implementation. So once a curriculum's written, what does this really look like in a classroom? But there are a few things I know about our Ontario math curriculum. It's built on theory and research about how children learn and ways to teach effectively. So quite often before the ministry revises their curriculum, they do a background research report where they look at what is the current research about how students think. What is the research around, let's say, learning trajectories? How do they develop mathematical concepts? And what does the research say about current teaching methods? And the curriculum then reflects that. It also recognizes, speaking of trajectories, this continuum of learning. And they also do a scan as to, so what are the other curriculums saying? And it's so much easier in this digital age to have access to other curricula and to look at, how do we compare? How do we line up? Where are other jurisdictions, particularly high-performing countries? Where are they teaching these concepts? What grades? And what does that look like? Also, the Ontario Math curriculum includes both math content, but mathematical processes. It really helps to describe, and I'm going to use a few examples, of what should be happening in a math class. And it really does describe the kinds of mathematical activity and actions that students should be engaged in, which then helps to think about, so what might a lesson look like? What might teaching be? So as much as sometimes we don't think the curriculum really gives us ideas about pedagogy, it actually does, and we'll look at the curriculum and see. So I know some of my work is not only doing research and teaching graduate courses, but I also help to prepare secondary mathematics teachers. So I teach in the teacher education program. And one of the most important things that I look for when my students are designing math lessons or implementing math lessons is I actually always go back and look at the curriculum expectations. What is it that you're trying to address? Because I find quite often what they're trying to address in the curriculum expectation are the nouns rather than the verbs. And we'll see exactly what it is I mean. So here's an expectation. It's a sample expectation from grade 9, and I've got a few expectations from different grades just so that you don't think this is just occurring in grade 9. It says students will identify through investigation properties of slopes of lines and line segments using graphing technology. And so what I really want to point out are these verbs. This really talks about the student actions that they should be doing an investigation, and that they should be using these particular tools, or at least have access to these particular tools. And I want to highlight that this is what students will be doing. So this is not about what the teacher's doing, it's about what the students will be doing. So that happens to come from the grade 9 academic curriculum. If I look at the grade, and I could have found a similar one in grade 9 applied, I don't want you to think that there's that big a difference. Grade 10 academic, students will plan and implement a multi-step strategy. They will verify. So we've got those particular actions that are right in that expectation. And if I bring up the example that they give, because the example is very important, then we also find that they will be doing other kinds of actions, such as verifying and checking, and again verifying. So if you read through that, you'll see that there's a variety of different verbs that are in there that will tell us exactly what it is the student should be doing. So again, thinking about, this is what students will do. It's not that teachers will plan and implement a multi-step strategy. It's that students will be doing that. So that's what I would be looking for in a classroom. Grade 11. So it doesn't stop after grade 10. And I find that we've done a lot of work in the province, particularly around grade 9. And I see a lot of really rich things happening in grade 9. I'll talk a little bit in a minute about a project I'm involved in with grade 9, because what I see is the people involved in that project are extending that learning to grade 10. But I find sometimes it's a little bit more difficult in grade 11 and 12 for teachers to be thinking about these kinds of actions. But this is the curriculum. So sometimes I hear, well, I don't have time for that because I've got to cover the curriculum. But you know what? These actions, these investigations, having students explain their thinking, this is the curriculum. And so again, this is what I would be looking for if I were in my role, or if you are in your role. So another one in grade 11, and this is so that it's in the Foundations for College Mathematics. So these actions are not just in those courses that are leading to university. They're in all courses that students will perform a probability experiment, represent, compare, Explain. So look at all those kinds of verbs that I should see students doing in a classroom. Not be sitting there and just watching the teacher, but these are the things that should be going on. And even in grade 12, so it continues to grade 12, students will make connections between graphical and algebraic representations and real-world applications. They'll identify, they'll explain, so many things there that are happening that students will be doing. So the actions that I actually see students will be doing, I pulled these from the curriculum, and I actually pulled them from the grade 11 and 12. They're also in the grade 9 and 10, but I filled the page with just actions from the grade 11 and 12 curriculum. Look at the variety of different things that students should be doing. They should be identifying, comparing, describing, explaining, interpreting, collecting data, determining through investigation. Sure, there's the calculate and solve, sketch, predict, expand, graph, gather, distinguish, evaluate. Think about those rich discussions that I would be hearing in a grade 11 and 12 classroom, and the actions, the activity that I would see in a classroom if students are doing those sorts of things. So what does this really mean? Well, for me, the verbs in the curriculum really describe what the students should be doing. They're the actions of students, not teachers. Sometimes people read the curriculum and see those actions as that's what the teacher is doing, but it's actually what the student should be doing. The student should be engaged in these activities. And often when I'm looking at a lesson that a teacher, one of my teacher candidates has designed, I often say to them, so within this lesson, 70, 75-minute lesson, who is doing the math? Because let's say in a traditional lesson, maybe one that you and I might have been a student in, quite often it was the teacher doing the math for most of that 70 or 75-minute period. But really, if we're addressing this curriculum, it should be the students who are doing math during most of that time. It's not about take up the homework, show you some examples, and do some more homework, which some people seem to feel is the three-part lesson. It really is about the student being engaged in that kind of work. And it's not just some students. So I think that this is really important. I think quite often people feel as though those students who are struggling learners, well, they can't really engage in those activities. They need a whole set of skills, so we better give them worksheets first. But actually, all students need to engage in rich math activity. All students need opportunities to develop their own strategies for solving problems. All students need time to investigate mathematical ideas. All students have the right to develop conceptual understanding and to feel valued as mathematical thinkers. And I think that's where that equity piece comes in. And I think that we're doing a fairly good job at this, but I think we can always, there's room for improvement. One research project that I did, which actually happened to be in Francophone schools, it was working with teachers over 2 years, and it was at the elementary level, but it was for those teachers to develop ways to allow students to develop their own strategies to problems and to facilitate the discussion between students as they develop their own strategies for solving problems. One of the biggest outcomes from that, as I did the focus groups with the teachers at the end of the 2 years, and when they talked about what changes they saw, first in their practice, but also in terms of the student learning, the biggest change that they saw was with their struggling learners. That when those struggling learners had the opportunity to solve problems in ways that made sense to them, as opposed to being shown how to do it, then they actually increased their confidence, and it also increased their achievement because they engaged much more in terms of the mathematics, and they saw that the way that they thought about these ideas, these mathematical ideas, and the strategies that they used were actually valued. So that's a really important message. I find sometimes that when people are trying to help struggling learners, they focus on the skills that they feel are necessary and might be giving them lots of practice and drill and worksheets. And it's sort of like doing 100 questions that they couldn't do before and they still can't do and still struggle with. Whereas engaging them in, I'll say, a rich task or a problem that has multiple entry points where everybody can begin the question, everybody could draw a diagram, or everybody could build a model, that then there's actually much more buy-in and they start to develop mathematical thinking, and they can see that the way that they think about things is valued. So um, I think that's an important message from some of what the research is saying. So what I'd like to do, I've talked for quite a long time, is I want to hear from you. So what do you see as some of the challenges with respect to mathematics teaching and learning in your own context? Because I want to talk a little bit about challenges and dilemmas, but I want to hear what it is you see. So Ben's opened the chat pod, and I know that some of you are in groups, so you might need a minute to discuss with your colleagues about some of the things you'd like to type in. But it really helps me to be able to draw on some examples if you can provide some areas that you see as challenges. So I'll give you a couple of minutes to do that.
Some of you did enter into the room after the conference began. One of the instructions was to put your thoughts into the pod that has the directed question. So if you could just please do that, that'd be great. Thank you.
Give you a couple of minutes. A few people are still typing, and also I know you're in groups, so you need a chance to chat about these things. Assessment's coming up big time, one of my favorite areas. Yeah, consolidation comes up a lot. Mhm. Give you another couple of minutes. It looks like we've got a long list of challenges. I guess that's why you're all here. It's interesting. Somebody wrote about delivering the curriculum. And for me, when I look at the curriculum, I don't see delivering at all. I see, and I'm sure the person who typed that sees that as well, that it really is about what students are doing rather than what the teacher's giving. So somebody asked about what are some of the strategies in other countries, um, which is quite interesting. I should maybe send a link. There are some video studies done through International. It's called the TIMS video study that actually has videos of what lessons look like in other countries. And the one I often use the video from Japan, where they begin with a rich problem and they asked the students to work on it on their own for a couple of minutes, and then they could move into groups if they want. They can get hint cards, and then students present solutions, and another problem is posed. So for some reason, we might think that they're doing worksheets in Japan, but actually they're engaged in rich problem solving. And if you just Google Tim's video study, you actually, not right now though, you actually would find some videos of teaching in other countries, and they actually make for rich discussion. So that could be. So a lot of your discussion had to do um, with with this notion of delivering the curriculum, seeing the content and not necessarily the actions. Um, some of you also are talking about assessment and kind of thinking about how do we help teachers move away from merely paper and pencil assessments to look at some of the other things. Even if I looked at those curriculum expectations that I showed you a moment ago, if I had to think about how would I assess those expectations, most of them actually would not be assessed with a paper and pencil test. Most of them I actually would have to do through observations, conversations, maybe a rich task where students explain their thinking. So again, if I were to be doing a talk about assessment, I would start with the curriculum and say, well, how actually could we assess these? And have a discussion about what that would look like. So there's so much that you're bringing up that is really important as well. I think a few of you brought up the idea that I was just reading the chat box on the side. A lot of you brought up the idea um, that sometimes if a student is not being successful, then the thought is that maybe they're just in the wrong stream, which is interesting. Okay, mindset comes up a lot as well. So great, you have lots of good ideas, and I want us to think about this um, within the context of dilemmas and challenges. So I'm going to move on with the slides, but I'm going to use some of the ideas that you have in terms of these dilemmas. So let me just click to the next one. So I want to look at a framework that I find is very helpful. And the reason I have that image up there is this framework I started to use with my work in assessment, because I found sometimes when I'm working with teachers, I often find that it was a bit overwhelming when the challenges that they saw, and it was a bit hard. How do I really help them? And it was to me a bit like this kind of ball full of elastics or a tangled yarn, and how do I unravel that? So I found this framework, and some of you who have heard me before might have heard me talk about the framework, but I want to use it with respect to the dilemmas that you actually had. And it talks about, let's look at these dilemmas in terms of kind of parsing them out into 4 different categories. And I'm not really one who loves putting things in boxes, but this helps me think about them a little bit more. And I'm going to talk about each one of these in turn. So conceptual dilemmas, pedagogical dilemmas, cultural dilemmas, and political dilemmas. And I think for many of the challenges that you posted, many I see falling into cultural dilemmas and conceptual dilemmas, and I think you'll see what I mean. I'll start with what I consider to be the easiest one, which is pedagogical dilemmas. This really is about how do I do this? So, in other words, quite often it's the kind of question a teacher might have, well, how do I find time for problem solving activities? And that's if it's a genuine question. If it's kind of a like, I can't do this because I can't find time, it might move into a conceptual dilemma. How do I find a rich task to use in a class? Where do I get that? Or some of you had one, how do I consolidate the learning? So what does that actually look like? And many of you talked about that, and that is something that we see in observations of teachers that they're working on. In other words, while one can facilitate a rich task, sometimes the consolidation part, they might have the kids share, but then what do they do? And that's an important piece. Or how do they develop strategies to consolidate? That's what I just said. Or create time to conference with the students and provide feedback. So those are really how-to things that I'll talk to about how to address it, but quite often that could be addressed with a good resource or a workshop. And there aren't too many things we can actually solve with a workshop, but some of these things we can, or with teachers sharing. So that's sort of one thing. Conceptual dilemmas are more difficult. Just like we talk about conceptual understanding of mathematics when we talk about students, we could talk about teachers or educators' conceptual understanding of why we're talking about teaching mathematics in these particular ways. They might say, well, sure, I'll do it, but not have that deep understanding. It's almost as though I remember the students who would come to me the night before a calculus test. Yeah, I don't need to understand this. Just tell me what I need to do to pass the test the next day. And so sometimes, and this is through no fault of their own sometimes new ideas come out and they appear to the teacher to be quite sudden, and they haven't had time to develop that understanding of why are we doing this? So in other words, they need the reasons, the evidence, the research. They need to try it out and see that it works. It's really about the why. So sometimes it's about being able to justify why they're doing particular strategies within their class, or evaluating why instruction and assessment needs to be aligned, or really recognizing what it means to understand mathematics. Sometimes it's about how do they think about mathematics? Do they see mathematics as a set of rules and procedures that we memorize, or do they see mathematics in a different way? So those are conceptual dilemmas, and you know what? A workshop's not going to do it to solve that problem, but we'll talk about how we could do that. Another are political dilemmas, and these really arise when people bump up against a particular policy. So one policy that people bumped up a lot is, what do you do when a student doesn't hand in an assignment? So I remember the controversy about what, you can't give zeros, when really, now this goes back to that conceptual understanding. What we were really saying is, if I don't have the evidence, I certainly couldn't give them a zero, because that doesn't tell me how that student achieved that expectation or set of expectations. I really need evidence to be able to talk about how they achieve it. But instead, it looked like a policy, and they were bumping up against it. Or dealing with departmental policies about consistency. So some departments make sure that every teacher is on the same page at the same time. And sometimes that's a dilemma for some of those innovative teachers who really would like to do things differently or try things in a different way. Or everybody has to write the same test. While it's a policy that might be good for consistency, sometimes consistency policies kind of have us lean towards what I would call the lowest common denominator rather than the innovative teacher. Or maybe it's having to organize marks for reporting in particular ways. So perhaps a teacher is struggling with tearing apart a performance task into categories for the achievement chart. So that might be a political dilemma for a particular teacher. But you might have political dilemmas as an instructional leader with policies your board might have or policy that the math department might have, and that might be something. But the biggest one, I think, that I suspect you're dealing with, and that many of the challenges that you talked about really focus on changes in classroom, school, and community culture with regard to how mathematics is taught. Sometimes they arise when we are suggesting new teaching practices and they threaten existing practices. So it could be student and parental expectations. I know that you, as instructional leaders, often are dealing with parents and parent comments about could be the way their students assessed, which might be different, or the way the mathematics is approached in the classroom, or it could be students. I remember when I was teaching calculus, a student said to me, math is not about, we happened to be having a famous mathematician party that day. It's not about famous mathematicians' parties. Math is about tests and quizzes, and that's it. So when I was trying to use some alternate assessment strategies, that student was threatened because they were comfortable with sitting, listening to math, and then putting it back on a test. Or it might be grappling with different teachers' approaches. So in other words, quite often there are cultural dilemmas that might exist within a mathematics department, that some teachers are moving forward and paying attention to those actions in the curriculum, and their students are engaged in activity, they're engaged in investigations, explaining their thinking, rich discussions, and there might be other teachers in the department who don't see the value in that or don't want their practice to include that. And so there are, I'll say, cultural clashes within that department. And also it comes in with the enculturation of new teachers. And I see this quite often. So I'm preparing people who will be secondary mathematics teachers, and some of them emerge from the program with some very new ideas. And sometimes they find that they've landed into a department that I would say might be very traditional. And sometimes it's very hard for those new teachers to be innovative because consistency seems to reign. And so they might not be trying out some of those innovative ideas. So I would encourage, as instructional leaders, that sometimes you connect some of those innovative teachers to maybe, if not other teachers in the school, then maybe other teachers in the school board. Maybe those are the people who get sent or to a professional learning workshop or are part of a professional learning community with other teachers, so that their innovative ideas might be encouraged. So my guess is that many of you might see some of those things you suggested as cultural dilemmas, perhaps conceptual dilemmas. Now, the other thing is, while I said I don't really like to parcel things in boxes because it's just not that simple, in a way, it helps me realize that I can't solve everything at once. Some things are going to take time. But also, I have to recognize that these things are interconnected. So, for instance, it doesn't make sense to invoke a policy without being aware of the implications conceptually. So, are we ready for this conceptually, or does some work need to be done around the conceptual understanding as to why this policy is in place? Pedagogically, so in other words, what does this mean for practice, as well as culturally? So, what kinds of things do I need to consider with this policy in terms of communicating this and helping different stakeholders understand this, because it's a shift in culture in a sense. So I'm going to look at just some ways of addressing the dilemmas, I'll say in general, but I might draw on some of the challenges that you presented. So as I mentioned, the pedagogical dilemmas I find to be, at least they feel like a shorter time frame and somewhat doable. They might be addressed through, let's say, workshops or more resources that teachers might need, or sharing practice, those kinds of things. And I'm sure you could think of other ways that they could be addressed. Conceptual dilemmas, I've got that little timekeeper there because they take time. They take time, they might take grappling with these new ideas. They might mean that teachers need access to current research or practitioner literature. that helps to explain why these things are happening, or maybe through conversations with colleagues. I often find that teachers develop a better understanding of why we're doing this when they try something new and see a positive change in student learning. Then they might often be surprised at what's happening. And also testing out those new ideas in a supportive environment. Quite often, we have to be careful. Sometimes when teachers test out a new idea, it doesn't work the first time. They might be putting the kids in groups of 4, and the kids have never been in groups before. So we have to think about ways to kind of scaffold teachers' learning and teachers' practice. The political dilemmas really, sometimes I think it means we have to question policy to see whether it actually aligns with current thinking. I know one example, for instance, that comes up quite often in elementary mathematics is that elementary teachers need to report mathematics on the report card. They need to report by strand. So they need to report on geometry and algebra and number sense separately. And for many of those teachers, it's a political dilemma because they're trying to do some rich problem solving with their students that's actually cross strand. And so when they go to assess it, they find it difficult to pull it apart. So really developing an understanding of the policy. So much as I said about the zero policy, so why is that? So developing that understanding, which goes along with that conceptual understanding, and also involving all stakeholders in the policy development so that that policy has some meaning. Cultural dilemmas, again, the timekeepers there, they take time. It takes time, it takes dialogue, it takes communication to parents and students. You need to support teachers who are trying out innovative practices so that they're not caught in a culture clash, and creating a culture that supports the risk-taking and providing opportunities for teacher dialogue. And I know that in secondary schools, actually, one study that I did actually showed that secondary teachers report more opportunities to have dialogue with their colleagues than elementary teachers. And probably that's because there's often a common department office. They might be teaching similar courses. So on a prep period or lunchtime, they might be talking about what they're doing in a class. But we still have room to increase that more. And so how can we support mathematics teaching? So I just want to give you some highlights of what we know about sound professional learning in mathematics. This is very specific to mathematics. The authors of this compiled research, and we're looking at how to support math and science teachers. And these are some key areas that it should be curriculum based. So that means dealing with the curriculum, but that also means engaging in the mathematical ideas in the curriculum. Sometimes secondary teachers teach in particular ways because that's the way they're most comfortable about those mathematical ideas. Sometimes when we talk about elementary teachers, we know that sometimes we need to work on enhancing their own math understanding because of the ways that they were taught. Sometimes the math is very procedural. And sometimes we assume that that's not true of secondary teachers. But again, secondary teachers were taught in very procedural ways. And so sometimes it can also, for them, be a bit threatening to open it up and to think about what are other ways to approach this. So examining the curriculum, looking at the next thing, focusing on student thinking. Quite often bringing in samples of student work and focusing on student thinking helps to take the emphasis away from what the teacher's doing and looking at, let's look at student understanding, and then what kinds of things can we do differently to enhance that understanding. Another one, it should be collaborative and within supportive school and district environments. So that's similar to some of the things I said. And it should align with other elements in the system. I actually think we're fairly lucky in Ontario. When I go and talk to colleagues in other jurisdictions, the US in particular, they're quite surprised by how involved math education researchers, as well as teachers and people who are leaders in math education, are involved with the ministry in the development of curriculum and other resources. And this means that when a teacher looks at the curriculum or when they go to a workshop, or when they read Growing Success, or if they were to read research literature outside of Ontario, they're all getting similar messages because it's fairly coherent. That's kind of an important thing, this coherence. So I feel that we tend to have that in Ontario. So what are some possible activities? And I'll talk about school PLCs, professional learning communities. Um, and I want to just talk about three different things that might be possible to do in a school. One is working together to look at student work. So that could be written work, video recorded discussions that students have, or conversations, and to really look and focus on student thinking and next steps. And I see doing that kind of activity as addressing pedagogical challenges, because one would talk about what one is doing in a classroom. If you're looking at student work, you'd be talking about the task. The discussion would help to facilitate cultural challenges, because sharing ideas and developing an understanding of how one another thinks helps. And then, of course, conceptual challenges, because you are rethinking how it is you think about mathematics teaching and learning. Another one you might want to consider is book study. Quite often a book study really, and I'll suggest a couple of books, really helps to draw on research. So it's like bringing in that knowledgeable other, but doesn't have to be there personally. Quite often a really good book to use might have samples of student work or samples of lessons, so that teachers could then have something to use in a classroom. And often a good book might have connections between pedagogy, math, and practice. So a couple of books that I've used, particularly around grade 8, 9, 10, that I've used with teachers. One is, and many of you know of, The Five Practices by Margaret Smith and Mary Kay Stein. The Five Practices kind of goes beyond talking about a three-part math lesson. The Five Practices talks about first choosing a task and anticipating what the students might do with it. So you're actually trying it out yourself, and this is the kind of thing that could be done within a group. And then monitoring as kids work on the task and taking note, so we move into formative assessment, of the different strategies that students are using. And then it moves into selecting and sequencing. So making decisions, not about just the best answers, but choosing which pairs or groups of students will share their work in a very purposeful way, so that you are perhaps choosing two that might connect, but maybe one used an algebraic solution and one used more a manipulative or a different representation solution, but they draw on the same mathematical idea. And then the fifth one is connecting. So that's our consolidation. So a lot of you talked about consolidation being a bit of a problem. And so the consolidation phase would actually be explained there. And I find that a lot of people have liked this book because it does have examples of tasks, it has examples of student work. So working through it might address some of those conceptual dilemmas, pedagogical challenges, because it does give some examples of things people could try out. And again, through discussion, those kinds of cultural challenges. Another book is by Joel Bowler and Kathy Humphreys, and it's called Connecting Mathematical Ideas. And I have a couple of grade 9 school teams who are using that book as a book study, and it actually comes with video of classroom. Now, it might be closer to grade 8 and 9 in terms of the kinds of things that they're doing, but that certainly the teacher moves and practices are kind of important things. And then another is maybe a lesson study. And so I've been involved with several school groups and PLCs who are basically working together. I've seen one group of grade 7, 8, 9 teachers work together to develop a lesson around integers, and it was tweaked for the various grades, but the teachers went and observed the lesson in each of those grades and focused on student understanding, and then debriefed not about how the lesson went, but how the lesson went with respect to what did the students understand, and then tweaked it together to improve. And so I think that working on lesson study, again, helps to address those those dilemmas as I have listed there. So just a few ideas, but my guess is you're already doing some of these things or already have some of these things in mind, or have done other things. So I'm going to give you a minute to share things that you've done to help to support mathematics teaching within your own context. And again, as a group, if you're a group, you might need to type some things, have a discussion before you type. So I'll give you a couple of minutes. And also, as people are typing, because we're all learning from one another, if you have questions for somebody about and you want them to tell you more about what they're doing, then please type that in. Some of these things are really good ideas. So I see lots of lesson studies and lots of connections around grade 7, 8, 9, 10. Instructional coaches, co-planning, co-teaching, lots of the things that I was speaking about I see are already happening, which is great. And a math network. Nice. I see a lot of things around grade 9 and 10 and 7 and 8. What are your ideas around grade 11 and 12? Sometimes that's a little bit harder. Anybody doing any work with grade 11 and 12 teachers? For some of these questions, also, I'm going to put up my email address. Like Sherry, I have a couple of rich tasks that you could use in grade 9 to 12. So I'm going to put this up so that if you email me, I can send you some ideas. So that would be true of anybody. Yeah, spiraling is happening in some places around grade 10 and 11. I also find sometimes that as teachers are working on grade 9, that moves into grade 10, and then some of that, because secondary teachers are teaching not only grade 9 but other, then it's starting to spill into some of the other grades. Yeah, good. That's what I'm hearing from Thames Valley. It is nice to see that those are spilling over into grade 11 and 12. I also think we can learn a lot from our elementary colleagues because they're doing many things. So I like to see that grade 7, 8, 9, 10 continuum because it's so important to learn from one another, and also just to for grade 9 and 10 teachers to see what kinds of things they're doing in grade 7 and 8. Yeah, the vertical whiteboards and randomized groups, that's really coming out strong. It's funny, in this grade 9 project that we're in, that seems to be sort of the material of choice that students, when they're working with a whiteboard, whether it's a vertical whiteboard or even one at the table, um, that they're much more likely to engage in trying something out because it can be easily erased, much better than chart paper. So it's interesting that such a simple idea seems to have such a strong effect on people's risk taking. Okay, great ideas. So I'm hoping that if any of you had questions about some of these things, um, you could ask one another. But great ideas. And I threw my email address up there. If you want a specific resource or idea, then feel free to email me after we do this. Okay, thanks so much. I wanted to talk about just with one slide. So right now we're in the second year of the OME Grade 9 Applied project. So this is a project that actually was funded by the ministry, and we have 9 different school teams spread throughout the province, really spread throughout. And each of those school teams is made up, I call it a PLC, is made up of an administrator, special education resource teacher, student success leader, grade 9 applied teachers, sometimes a math board lead, department head, and they have the support to have a release day, one day a month, and they are working together to think about their instruction in grade 9 applied. And they're doing a variety of different things, many of the things that we talked about, the book studies, the lesson studies, examining student work. And this is year 2. And some of the things that we're actually learning, besides all the things that they're doing, are really that the support of the administrator on the team is key. And we've been bringing these teams together. We brought them together this past summer for a summer institute. And as they started to share across teams, that was huge. So not only is the collaboration within the team, but it's also across teams. And we also see that it's a supportive environment for the teachers to try out new ideas and to come back to the group and say, you know, this work didn't work, and get support rather than criticism. And a lot of the work that they're doing is really focusing on the student understanding. So while they're changing and shifting practice, they look at the response. And a lot of the work is also around unpacking the curriculum and what is the curriculum really saying. And it seems the curriculum has been around for 10, almost 11 years now, but we're still looking at what is that saying, or maybe we've forgotten about it, so we're going back to it. I also wanted to share with you that because we find this learning to be so important, one of our deliverables from this research project is actually that we're putting on a conference at the end of August, this coming August, that's open to other schools so that these 9 school teams can share their learning and I can share the research. And so it's a 2-day conference, which you might have received information about. It got sent out to all OAME members. It got sent out to directors of school boards. But it's the cost is very minimal, transportation, etc., is covered. So it might be something you want to look at. And if you haven't heard of it and want info, again, you could email me and I can send you that. I'm not trying to sell it. We don't get paid for it or anything. But for me, it's an important deliverable rather than just a report that one writes, but to share their learning kind of across the province. So sometimes the question comes up, well, why should I do this in grade 11 and 12? Because what's going to happen when they go to university? And I want to talk about what does happen after secondary school. They might go to university, they might go to college. And I think that much as our grade 9 teachers, our grade 8 teachers thought that they had to do particular things to prepare them for grade 9, quite often they were preparing them for a grade 9 that they went to, not the actual grade 9 that's happening now. I think the same is true for grade 11 and 12 teachers. I think that they think that they're preparing them for university. And in many cases, their view of university is the university that they went to in their university math classes. Now, I'm not saying that everything has changed, but I do know that there are many projects occurring in Ontario universities around mathematics. And these are just a few that I know of that I'm involved in. At one university, I know that the prof in first year calculus uses portfolio assessment. And so the students have to submit within their portfolio evidence of particular concepts. In another university, I know that at a graduate level mathematics course, the professor actually asked for my help because he wanted to develop more collaborative problem solving and the use of formative feedback. In another university, I just saw a presentation this past weekend that they are using writing and having students write about their thinking in a second year differential equations course. And they're looking at the impact of that writing. They're having some cultural challenges there because some of the kids are saying, math isn't about writing. Why do I have to do this? But they're also finding evidence that this is enhancing their understanding. In another university, in a third year geometry course, they are doing investigations using dynamic geometry software. Now, those are not the only 5 things occurring in the province. That's sort of all I could fit on the slide. There are many other things occurring. And if I were to pull out a journal in higher education or some of the research journals, you would see that there are many research reports of people in university mathematics courses trying different sorts of things within their class. I'm not saying it's happening everywhere with every prof any more than we would say it's happening in every math class in Ontario in high school, but it is happening. People at the university level also pay attention to what the research says about mathematics teaching and learning. I know, for instance, at the University of Ottawa, there's a whole department set aside called the Teaching Learning Support Services that provide workshops about incorporating technology in your class, about how to have more group work in a large lecture hall kind of setting. And so I think that we need to think about the fact that actually some of these trends that we see and people paying attention to what's good teaching and learning in elementary and secondary school is also happening within Ontario universities. So there is evidence that these things are happening. So really for me as well, so when some people say, well, why should they use technology? I hear at such and such a university, they can't use calculators. Well, the best thing we can do to prepare students for post-secondary education or work is to deepen their understanding of mathematics. So if we know what are some of the best ways to deepen their understanding of mathematics in secondary school, that's what we should be doing, whether or not they're going to have that tool available to them in university. Let's give them the kinds of tools and experiences that will give them a rich understanding. And I also know that having students work collaboratively to problem solve is going to be an excellent preparation, whether they're doing it in class in university. They'll probably need to do it outside of class to make sense of what's happening in class in university. So they'll be ending up doing it informally anyway. So I just want to make sure those messages get out there as well. So in summary, what are some of the, I guess for me, big ideas that Ontario actually is doing well with compared with other jurisdictions in terms of achievement as well as equity? That the math curriculum is actually sound. It compares well with other jurisdictions, and it really suggests the actions that students should be doing in classrooms. And for me, as I say, I always go back to the curriculum to if I'm looking at a particular lesson that is occurring in a classroom. The dilemmas and challenges that we face, they take time, they take shared expertise, they take resources, they take access to research in whatever form that could be. And there's a lot out there that's really accessible, and collaborative communication within a safe space. And really focusing on developing student understanding in mathematics classes, as well as a focus of that in professional development is important. So I find understanding in terms of, for teachers, it's not just mathematical understanding, but pedagogical understandings and conceptual understanding of what good pedagogy looks like and why one does those kinds of things. So really, I think both teachers and students need time to grapple with ideas in order to develop that understanding. And I think we need to recognize that it takes time. It takes time. We can't rush through the curriculum. We can focus on the big ideas in the curriculum, but it also takes time for teachers to grapple with some of the new ideas around pedagogy and mathematics. And we need to provide them with opportunities and a safe space in order to be able to grapple with those. And so I'll just leave this to some questions or comments that you might have. We've got a little bit of time where you could type in some questions. And as well, once we discuss some of the questions, we also are asking for some information about areas of the webinar that you found, I have to open this up, useful, and other areas. So we've got a couple of questions coming up. Anybody have questions?
Chris, if I could just step in here for a second while people are
Sure.
contemplating and writing in their questions. For those of you who did want a copy of the presentation, if you'll notice in the middle of your screen under the downloads, there is a listing there for enhancing secondary mathematics. If you click on that and then click the downloads file, which will highlight after you click on it, it'll take you to another tab. In that tab, you'll be able to download the file, and then you can come back and once you close that file, that tab, you'll be right back in this platform. So feel free to do that as well.
And so Jacqueline wrote, I find that dilemma framework kind of nice. I find it useful. It helps me kind of not feel overwhelmed with the kinds of challenges we have. Marissa, I don't really have a good answer for why universities insist on calculus as one of the prerequisites. Sometimes I feel as though universities maybe are using some of those kinds of things as filters, or they might be thinking that um, some of the kind of logical thinking and reasoning that one does in those kinds of courses, the upper level math courses, might be the kinds of things that you would need in medicine. I mean, in medicine, there is quite a bit of math that's involved when we're thinking about dosages and we're thinking about exponential growth of bacteria and half-lives of medications, antibiotics that we give. So there is some math that's going on in some of those, and it is kind of nice to have a bit of an understanding of that. Yeah, I totally believe Upper Canada District School Board comment about what high schools can do to prepare students for university. So I think no matter what, it's deepening understanding of mathematics. That would be true of primary teachers to prepare students for junior. I agree. Um, so I think that's true all the way around. And I know that sometimes people feel that they need to tick off every curriculum expectation, but often they can be clustered. And I'm hoping, because they're looking at reviewing the math curriculum in Ontario, I'm hoping that they'll think about doing something like that in terms of clustering those expectations so that we get a sense as to how they fit together. The other thing I find sometimes when people feel that they need to cover every expectation is that I think it's important to look at the grade before and the grade after, because really you need to think about, for this particular concept, what's new, and that's the part I focus on. It's not so much that I need to cover everything about integers, because I can look at what they've done before that might need reviewing, but then I can focus my attention on what's new. Yeah, Mirza, I don't know about whether that course would be sufficient for that. I don't have anything to do with the university requirements for the math program, so that's a good question, though. Yeah, lots of good suggestions for other webinars. The differentiating assessment and evaluation in secondary math is, well, assessment is my area. So um, some examples of that I think would be really helpful for everybody. This notion of deepening understanding, again, I find that if we actually address the curriculum, um, it would it would actually deepen understanding. If we gave students those experiences that are suggested in the curriculum, it would deepen that understanding. Your feedback's really helpful in terms of what things made sense to you and what things worked. I'm glad to see so many people like that dilemmas framework, because I find it useful. It just makes it a little more manageable.
Chris, there is a question for you in the what area in the webinar would you like to explore further from Sherry?
Okay. Do you provide math talks in districts for secondary math teachers and admin? So do you mean, do I go out and speak to them? Is that what you mean, Sherry? I guess it is. Um, yeah. So yes, um, I do. I mean, I'm busy with teaching and research and all of those things, but as much as I can, I do like to talk. I think it's important to talk to teachers and work with teachers. One of the activities I do often when I'm working with secondary teachers is we look at the grade 9, 10, 11, 12, and I kind of divvy it up, and I hand out sticky notes, and I ask them to write the verbs on the sticky notes from the curriculum. So we post up, I might even do 7 and 8, we post up the verbs all along the wall by grade, and then that sits there all day long as we talk about what does math look like in a classroom. And it reminds us that that's what we should see students doing. And I think that's important. So we had a question interested in the portfolio approach and the writing about what students learned. Yeah, So I see Simcoe County is promoting the OEME conference, which is great. So the portfolio approach, I think that approach is fostered in many places. I've seen people use a portfolio approach in grade 9 where the portfolio is focused around the mathematical processes. And so students gather over time pieces of work that might address each of those mathematical processes. They might include work where it showed that they selected tools and strategies, or a piece of work where they showed that they were representing in different ways. And so that's one way. Other people have done portfolios where they have the overall expectations, and students include pieces of work that demonstrate that they've achieved those overall expectations with a reflection as to how that demonstrates that. It's interesting because that becomes both a formative assessment tool as well as a summative assessment tool. So that is interesting. Yeah, so the other thing some of you are asking about, kind of more of this, is you might be interested in attending that conference in August. It's 2 days. There's one that's going to be held in Toronto and one that's going to be held in London. And we'll be sharing some of the learning from the school team. So there'll be discussions about rich tasks, about the use of technology in grade 9 applied mathematics. There'll also be discussions about the curriculum and different ways that people rearrange that, how they approached algebraic thinking, trying to think of some of the other things, as well as there'll be, so we ask when people register for that, they actually have to register as a school team, an administrator, a math or board lead, a grade 9 applied teacher, and it could possibly be another grade 9 applied teacher or the student success teacher or a grade 10 applied teacher, and to come as a team. And we also will spend some time where the administrators get together, and the administrators who are part of the project share some of the things that they did to support the learning. The facilitators will talk about how they shared the learning. We'll talk about some of the book studies that were done within the context of that. And we'll also talk about how that learning spread to grade 7, 8, and then moved into 9 and 11. So it might be a great professional learning opportunity. And we'll also give you time to think about other ways to continue on your journey of enhancing math teaching and learning as a school team. So that's another opportunity for you.
As long as we're promoting things, March 10th, we are lucky enough to have Chris present again. So keep an eye out for that. I believe the communication for registration is going to be going out during the week of the 22nd of February, so rather soon. That being said, I want to thank all of you participants who have shared with us and have made this a really valuable learning experience. I want to thank Dr. Chris Suurtamm, who, as always, has done a phenomenal job here today. And I'm just going to pass it back to her so she can say her final words. And to the rest of you, hope to see you again.
Okay, thanks everybody. You were very engaged and you had so many wonderful ideas. It's so nice to participate in this. And when you type in the kinds of things that are happening in schools, it's just wonderful to see. And I think it's the work that you do and the work that your staff does that puts us up there and high in those international placements around equity and improving math for all students, as well as high achievement. So take care. Have a really great afternoon and a good weekend. Thanks, everybody.